first one is f of x equals x minus 1, but only if x is less than or equal to 3. And f of x will equal negative 1, but only if x is greater than 3. So I'm going to graph the piece of each function. You may want to make a little note to yourself, okay? Always look at, we could call them transition points or end points. A little note to myself. So I always have to look at these guys, because 3 is where I switch from one to a different function. If I'm less than 3, I use the top one. If I'm equal to 3, I use the top one. If I use greater than 3, then I look at the bottom equation. So the best way to do this is to break it apart. This is graphing y equals x minus 1, this function, as long as x is less than or equal to 3. But I'm graphing this function, y equals negative 1, if x is greater than 3. Now, I need to start my graph with this transition point, this endpoint. I got to know what happens at 3. So I can make myself a table when I don't know how to graph. X is the one I manipulate, play with, change, input. It's my independent variable. And y will be equal to whatever x I pick minus 1. Well, for this graph, I'm picking x's that are less than or equal to 3. So 3, 2, 1, 0, and so on. So if I were to plug each of those x's in, I could find the y coordinate on my graph. So if I plug in a 3, what's 1 less than 3? 2. What's 1 less than 2? So those are the points that I plot on my graph. So I'm going to go over here and I'm going to plot, let's see, 3, 2. 1, 2, 3, up 2. And it's a closed circle because x is less than or equal to 3. So that is a closed circle. Then I'm going to plot 2, 1. I'm going to plot 1, 0, 0, negative 1. I'm going to plot the whole linear equation, x minus 1, but I'm only going to plot it for x's that are less than or equal to 3. So if I'm graphing this, I'm only graphing to the left of where x is 3. What's my slope of that graph? Positive, negative, what is it? Positive 1. It's the coefficient in front of x. There's an understood 1 there. So I could go down 1, left 1, down 1, left 1, and keep graphing my slope of 1. This is what it looks like, to graph y equals x minus 1 on the domain that's restricted to where x is less than or equal to 3. I'm only graphing it for x is less than or equal to 3. I could graph the whole thing, but then I'd have to erase any of the parts where x is greater than 3. So it's easier to just start at 3, figure out where my points are, and graph my graph. So if I want to graph the second part now, I want to graph everywhere y is equal to 1, but it starts at 3. Now what kind of circle am I going to have at 3? An open circle, because x is greater than 3, but I still have to plot that point because x could be anything greater than 3. It could be 3.0000000000001. That's greater than 3. It could be infinitely close to 3. So even though 3 is not included, I graph it with an open circle. So you may want to write a big note to yourself. Even though 3 is not included, graph it with an open circle in giant letters, because that's the biggest way you're going to make a boo-boo. Well, x is what I manipulate. Y will always be on this graph what? Everywhere on this graph, y will be? Y will be negative 1. So negative 1. Pick a number greater than 3, that's 4. Y will be negative 1. Another number, that's negative 1. It's a constant equation, right? I have a linear, I have a constant. Y equals negative 1 is a flat line, but I'm only graphing it starting at 3. So over 3, down to negative 1 is my open circle. There's y equals negative 1. I graph for a piecewise function the pieces of each function. And I only graph the pieces based on what domain it tells me to. I only graph this one for those x's. And I only graph this one for those x's. So I'm given each piece, and I'm given where to graph it when I begin. Now, what's the domain? So the arrow to the left tells me the x's keep getting smaller. The arrow to the right, x's keep getting bigger. The only place I have a potential is the middle here where my graph is broken. But I have an x equals 3 in my graph. So we're okay. I could even look at the domain from the original function. I'm going to graph this one everywhere x is less than or equal to 3. That's negative infinity. This one everywhere x is greater than 3. That goes to infinity. The only place I might have a problem is where? At 3, because it's where I jump from one graph to the next, but it equals 3, so it's all real numbers. Because this little arrow right here tells me my graph keeps going in this direction. I'll run into this. All right, now what's my range? My range are my y values, my output, my dependent. So if I read that from the bottom to the top, what's the floor of this graph? All right, and then I come all the way up my graph until I get to a highest y value of 2. So I can say y is less than or equal to 2, or I can say negative infinity to 2. Absolutely. Depending on how you like to draw them. All right, I'm going to change this one. Hold on. We're going to, because I want you to have one with 3 that we practiced. So here's my piecewise function. We're going to graph the function f of x. It's equal to 2, where x is less than or equal to negative 2. It's equal to x plus 1, but between negative 2 and 2. It's equal to 3x, but only for x greater than or equal to 2. So I now have 3 pieces that I'm going to graph separately. So the easiest thing to do, I'm going to write each one separately. F of x is the same as y. Y equals negative 2, everywhere x is less than or equal to negative 2. So I'm going to start at negative 2 for my x's. And if I plug in negative 2, what's my y? Negative 2. What's my y everywhere on this graph? Negative 2. So a number less than or equal to negative 2 might be negative 3. And y is still negative 2. So if I know my starting point right here, he's a closed circle because it's less than or equal to. So negative 2 is a closed circle. I'm going to graph the horizontal line, y equals negative 2. It's a constant for all the x's that are less than or equal to negative 2. So all the x's in this direction. My slope is 0. I go up nothing, over something. Right? Now I'm going to graph the second part. I'm good with him. I'm going to graph y equals x plus 1. What kind of equation is that? Linear. What's his slope? 1. But I'm only going to graph him where x is greater than negative 2 and also less than 2. Now, even though these endpoints aren't included, I have to graph them as open circles. So there's going to be an open circle at negative 2. Greater would be negative 1, 0, 1. All the way up to 2, there's going to be an open circle at 2. I have 2 endpoints here. I have to graph both of them. So if I plug in negative 2 plus 1 would be negative 1. If for x I plug in a negative 1 plus 1 would be 0. So I could graph these points. Negative 2, negative 1 would be an open circle. If I plug in this last endpoint here for 2, 2 plus 1 would be 3. So over 2 up 1, 2, 3 would be an open circle. And what's my slope everywhere along that linear equation? Right here, 1. So if I have 2 points, I can use the slope to count the other points. Up 1 over 1, up 1 over 1, up 1 over 1. There's my linear equation. Now I'm going to graph the last one. I'm going to graph y is equal to 3 times x, but I'm only graphing that where x is greater than or equal to 2. So I'm going to start when x is 2. I'm going to plug that in. 3 times 2 is 6. Open or closed? Closed, because x is greater than or equal to 2. So over here at 2, up 1, 2, 3, 4, 5. We'll kind of go all the way up there to 6. Let's do this. Let's come down a little so I have some room. What's my slope? Here's my equation. What's my slope? No? That's my slope. There is no x in slope. 3 is the coefficient in front of x. Slope is m in your equation. There is no x in slope. So I go up 3 over 1. So up 1, 2, 3 over 1, up 1, 2, 3 over 1, and I go for all the x's greater than 2, so it keeps going. No? We start at 2, 6. We start wherever it tells us to. It tells us to start where x is greater than or equal to 2. So I plug in 2 for x, and I get 6 for y. The slope right here is 3. 2, 6. Now, if I'm looking at this graph from left to right, the left-hand side keeps going smaller, the right-hand side keeps getting bigger. There's a great likelihood my domain is all real numbers. I just have to check where I jump from one graph to the next. All of my x's are accounted for. So this graph doesn't have a -2, but he does. This graph doesn't have a 2, but he does. So there's no breaks in my graph where an x doesn't exist. So my domain is -infinity to infinity. My range are my y values. So what are my y values? I have a break, though. I have a y value here at -2, and then my graph jumps up here, and then it jumps again from here to here, and then it goes to infinity. So my range is pretty gnarly. So if I'm looking at this graph trying to figure out the range of the graph, my lowest y value is what? -2. So I know y equals -2. Then I jump and I start from here at -1 and I go up to here at 3. So then I say y is greater than -1, less than 3, because those are open circles. And then I jump again, and y is greater than or equal to 6. So I can list them all separately. I could say -2 union -1, 3 union 6 to infinity if I really wanted to do interval notation. If I have lots of breaks in my graph, I'm going to have a really funky domain array. That's how we graph a piecewise.